In lesson 21, we'll be learning about the product rule for exponents, and then we'll also be learning about addition of like terms with exponents. To understand the product rule for exponents, let's just start with an example. If you had 2 squared times 2 to the third, that's going to equal 2 to the fifth. Now, why is that? Well, just think about it. You know that the power rule is anytime you have that exponent there, 2 squared, that's the same thing as saying 2 times 2. And then 2 to the third is also multiplied there by 2 squared, so that would be 2 times 2 times 2. And so you have 2 multiplied out 5 times. 2 is a factor 5 times, or 2 to the fifth. So just like if you had 2 squared times 2 to the third, what if you had 2 to the a times 2 to the b, where a and b are variables, and those could be any values that you want to put in there? Well, that would result in 2 to the a plus b, right? Just like 2 squared times 2 to the third is equal to 2 to the fifth, or 2 plus 3. 2 to the a times 2 to the b is equal to 2 to the a plus b. And then we can take that even one step further. Instead of having a 2 there, you could have any variable. It could be a 3, a 5, anything. So let's just say x to the a times x to the b. That is equal to x to the a plus b. Now, the reason you need to understand this is because you'll be working with some problems where you'll have to simplify an expression of factors, and you do that by adding the exponents together where there are similar variables. A couple of other things to consider: when you just have like a variable x, that's the same thing as saying x to the power of 1. It's always understood that it's to the power of 1. That's just another definition that we use in mathematics. By definition, if you just see a variable or a number by itself with no power, that means it's raised to the power of 1. Well, let's use the power rule or the product rule to simplify some expressions. Look at practice problem A. X cubed times x times y times x squared times y to the fourth. So we could simplify that if we use the product rule for exponents. And one thing we could do here is to put a 1 next to those variables that don't have an exponent, because we know that we're going to be adding, and we know that that's the same thing as a variable by itself is the same thing as that variable to the power of 1. Now, another thing we can do, we know in multiplication that the order of the factors does not matter, so we can get all the x factors together and all the y factors together. And so let's just do that. X to the third times x to the 1 times x squared times y to the 1 times y to the fourth. Now, one thing about the product rule, you have to have similar bases or variables. You can only add the exponents of similar bases. Like, for example, I can't add x squared and y to the 1 and get like xy to the third or something like that. I have to just add exponents of similar bases. So that's why I got all the x's together and all the y's together. Now I can just go ahead and add. And I look at the x's and I have 3, 1, and 2. So that would be 4 plus 2 is 6, or x to the sixth. And then my 2 y's, I'll add those exponents together and I get y to the fifth. So that's the simplified form of that expression. X to the fifth times y, x to the sixth times y to the fifth. Look at practice problem B. Let's simplify that expression. And so just look at it and look for similar variables. And so we have some x's in there and some y's in there. The a and the b, there's nothing else similar to them. And so let's just leave those at the front. And let's rearrange. A, b, x to the fourth, x to the third, y. And let's make that y to the 1 and y to the third. And that y to the 1, that just helps us remember to add 1 there. And so to simplify this, we'll say AB x to the seventh, y to the fourth. So that would be the simplified form of that expression. So some things about the product rule. It's real important to understand that when you have similar bases multiplied together, you can add the exponents. And then when you have a problem where you have a bunch of terms in it and you can simplify that, rearrange those bases and so that you can kind of get them all together, and that way it just kind of helps you get organized and help you clearly see what exponents you're going to add together to simplify that expression. In part B of this lesson, we'll be doing some addition of like terms, and some of these terms will have exponents. Now we treat these just like the other addition of like terms problems that we've had. We use our same rules when we're trying to figure out if one term is similar or like another term. We don't worry about the numerical coefficient. We just look at the variables that are included. And now we'll have to look at the exponents as well, because the exponents for each particular variable have to be the same as well. Look at practice problem C. Let's simplify this by adding like terms. And so let's just kind of look through the problem. We have 3xy to the fourth plus y to the fourth x minus 3y squared. Now the difference, like we were saying, between this problem and other like term problems we've been doing is that now you have to match up the variables as well as their exponents. So we have 3xy to the fourth. Do you see anywhere else that there is an x times y to the fourth? Well, that third term there is xy to the fourth, right? It's just in a different order. It's y to the fourth x. But we know that in multiplication the order doesn't matter. So those two are like terms. They both have a y to the fourth in them, and they both have an x. Now the other two terms, the y and the y squared, those would not be like terms because they are not to the same power. The first one is just y to the power of 1. The second is y squared. So we can't say that those are like terms because their powers are different. So that's real important to understand. If their powers are different, they are not like terms, even though the variables are both y's. Okay, so let's go ahead and add these two together. 3xy to the fourth plus xy to the fourth, or 1xy to the fourth. That would just be 4xy to the fourth. We add the coefficients, or the number parts, together. And so we get 4xy to the fourth, and then plus y minus 3y squared. So we've simplified that to 3 terms now instead of 4. Let's look at another one. Simplify this by adding like terms. 2x squared y squared minus 5xy plus 4y squared x squared minus 7yx squared plus 3x squared y. So let's go through here and look for like terms. We have 2x squared y squared as the first term. Do you see any other x squared y squareds in there? Well, if you look at the third term, it's y squared x squared, but that's the same thing. The order is just different, and the order doesn't matter in multiplication. So we put a red line under those to designate we have 2 like terms there. Now let's keep looking. We have an xy, or minus 5xy. I don't see any other xy's in there, so that term is by itself. And then we have 7yx squared and 3x squared y. Well, those are like terms, right? Because they both have an x squared and they both have a y. And so I'll underline those in blue so that will help us remember that those two are like terms. And again, that's something you might want to do as well, is to underline your like terms in a different color, and that way you can distinguish those. Now let's go ahead and add them together. 2 and 4, that would give us 6x squared y squared. Then we'll just say minus 5xy. And then we have negative 7 and positive 3, so that would be a negative 4x squared y. Okay, so that's our simplification of that expression. And again, remember, like I said before on these addition of like terms problems, when you have your answer there, the order that you put the terms in does not matter because it's just addition. But if you have when you simplify them, if you simplify them incorrectly, then that's wrong. could have put that minus 5xy in the middle like I have it there, or it could be the first term or the last term. It doesn't matter where it's placed as long as the whole term itself is a minus 5xy. Let's do one more problem. Let's simplify this by adding like terms. And so look through it first and see if you see any like terms. You've got x cubed y squared, and like I've been doing, maybe you didn't notice it, but what I like to do is just pick one variable out with its exponent and see if that variable and exponent is found anywhere else in any of the other terms. So like in the 4x cubed y squared, just take the x cubed and see if any other terms have an x cubed, and they don't. So that is not going to be a like term with any of the other ones. So just go ahead and go on to the next one. X squared y cubed. Do any of the other terms have an x squared? Well, that third one does. Does it have a y cubed? Yes, it has a y cubed as well. So those last two are like terms, and so we can just underline those in red. And we have minus 2x squared y cubed and plus 2x squared y cubed. So those are just going to cancel each other out, and we just end up with 4x cubed y squared. So in order to add like terms, or in order for them to be called like terms when they have exponents, they have to have the same variables, and those variables have to have the same exponents as well. Okay, well that's all for lesson 21.